Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be looking at the three forms of linear functions that we've learned in this unit. We'll be comparing how to graph with each form and how to use each form to find the critical attributes of the functions such as intercepts, slope, and zeros. Let's start off by reviewing the equations for each form and how to graph each form. So the first form we learned was slope-intercept form, and the equation for slope-intercept form is y equals mx plus b. To graph slope-intercept form, you plot the b and use the slope to find additional points. The next form we learned was the point-slope form. The point-slope form is y minus y1 equals m times the quantity x minus x1. Now to graph point-slope form, you plot the x1, y1, then use slope to find additional points. And the final form of linear function that we've learned in this unit is standard form. Standard form is ax plus by is equal to c. Now, in standard form, it's not very easy to see what the slope is. So for standard form, you identify the intercepts, then plot, then connect. Now let's look at some examples for each one of these forms. So in example 1, it says graph the line represented by each equation and answer the questions. So in problem A, we have 3x minus 9y is equal to 18. They want to know what form is the equation written in. B, they want to know what is the slope of the function. C, what is the zero of the function. And D, what is the y-intercept of the function. Now, in case you haven't learned this term yet, the zero of the function is the same thing as the x-intercept. So I just wanted to review a little definition there just in case you haven't heard that term before. All right. Now, first of all, let's start with what form this is in. 3x minus 9y equals 18. Because our x and y are on the same side and the constant term is on the opposite side, this would be standard form. And to graph standard form, we want to identify the intercepts. So let's find the x-intercept first by saying 3x is equal to 18. Therefore, x equals 6. And negative 9y is equal to 18. Therefore, y is equal to negative 2. Now, once you know the intercepts, then you're going to plot them. So on the x-axis, you'll put a dot at 6. On the y-axis, you'll put a dot at negative 2, and then just connect those points. So it's very, very easy to find the intercepts when an equation is written in standard form. Now, the downside to standard form is it's a little bit harder to determine what the slope is. So we will use the intercepts to find our slope. So let's get our rise, which is 2, and our run, which is to the right 6, so positive 6, and then reduce that. So the slope of this function is 1/3. The slope of the function is 1/3. Question C says, what is the zero of the function? And I told you that the zero is the same thing as the x-intercept. So the zero of this function was x equals 6. And the y-intercept is where it touches the y-axis. So it touches the y-axis at 0, -2. All right, problem B. Our equation is y equals -1/2 x minus 2. Now look at the chart up here and try to decide which form this equation is written in. All right, hopefully you said that it was written in slope-intercept form. Now, our chart at the top says to graph slope-intercept form, you plot the b and then use the slope to find additional points. So in slope-intercept form, the slope is the coefficient of x, and the b here would be 0, -2. So we'll plot the y-intercept, and then we'll use our slope to find an additional point. So we'll go down 1 and right 2. Okay. So question B, what is the slope of this function? -1/2. Question C, what is the zero of this function? Right now, we only have 2 dots, so we can't really tell what the zero is. So what I'm going to do, I can tell it's going to touch the x-axis somewhere over here. All right, it's going to touch the x-axis somewhere over here. So what I want to do is use my slope to find additional points. So for my first point, I went down 1 and right 2. I'm going to go the opposite way. I'm going to go up 1 and left 2. Do you see how that would end up on the same exact line? Now let's do that one more time. Up 1 and left 2. Now we've got our x-intercept. So I can connect this line here. So now we know the zero of the function is at -1, 2, 3, 4. 1, 2, yeah, right here. That's your zero. I'll label it. So our zero was x equals -4. Now the y-intercept was 0, -2. We already knew that. All right, problem C. Y minus 4 equals -1/2 times the quantity x plus 2. All right, so look at the chart above and try to figure out what form this equation is written in. All right, hopefully you put point slope form. Point slope form. Now, in point slope form, we want to identify our point. So for the point, it would be -2, +4, and our slope is -1/2. So I'm going to put a point at -2, 1, 2, 3, 4. Then I'm going to use my slope, which is -1/2, so I'll go down 1 over 2. Now I'm going to keep that going so that I can find the zero of the function. Down 1, right 2, down 1, right 2, down 1, right 2. All right, now that I have all this, I should be able to answer all the questions. So we're going to answer question B. What is the slope? Well, that was -1/2. What is the zero? Well, remember the zero is where it touches the x-axis. So that would be x equals 6. What is the y-intercept? That was where it touched the y-axis. So 1, 2, 3, 0, 3. So there's all 3 forms that we've learned in this unit. Standard form, slope-intercept form, and point-slope form. All right, example 2. Graph the line described and then answer the questions. So in problem A, it says we have a line that has a slope of 3 and passes through -2, 6. And they want to know the y-intercept, the zero. They want us to write an equation for the line in point-slope form, and write an equation in slope-intercept form. Okay, so let's start with graphing the line described. All we know about this line is it goes through -2, +6. So left 2, up 6. Okay, so there's our point. That's our x1, y1. We also know it has a slope of 3. Now, if we write 3 as a fraction, we will know our rise and our run. So +3 means go up 3, right 1. So 1, 2, 3, right 1. And we do that one more time. 1, 2, 3, right 1. The reason I'm doing that one more time is I want to know where, if I extend this y-axis, where would it touch the y-axis? So if this was at 6 and we went up 3, this was at 9. And if we go up 3 again, it would end up at 12. All right. Now let's go the opposite way and see if we can figure out where it touches the x-axis. So I'm going to go down and left. So 1, 2, 3, left. 1, 2, 3, left 1. 1, 2, 3, left 1. And now we can draw in our line. So our y-intercept, where it touched the y-axis, was at 0, 12. The 0 of the function was x equals -3. Let me highlight it for you right there. Now write an equation in point-slope form. So in point-slope form, I would take my y minus y1, which was 6, equals m, which was 3, times the quantity x minus x1, which was -2. Then I'll simplify it so that I can eliminate the double operation signs. So y minus 6 equals 3 times the quantity x plus 2. Now, the next thing they want me to do is write the equation in slope-intercept form. So for slope-intercept form, I need y equals mx, so that would be 3x, plus b, and the b was 12. So there's our equation in point-slope form and slope-intercept form. All right, next question. They want us to draw a line that passes through 1, -4. So right 1, 1, 2, 3, 4, and 4, 2. 1, 2, 3, 4, 1, 2. All right. Now, right now, we do not know the y-intercept. We do not know where this line is going to touch the y-axis. So to figure out where it's going to touch the x-axis, or the y-axis, I want to find the slope. So my slope, let's see what the slope of this line is. 1, 2, 3, 4, 5, 6. And 1, 2, 3. So I know my slope is 2. So I'll start with this bottom point and go up 2 over 1, put a point, up 2 over 1, put a point, up 2 over 1, and there's already a point there. Now let's go the opposite direction. Let's go down 2 and left 1. So down 2, left 1. Aha, now we found the y-intercept. Okay. All right, so question A, what is the y-intercept? Well, the y-intercept is right here. 1, 2, 3, 4, 5, at -6. Next question, what is the 0 of the function? The 0 is where it touches the x-axis. So 1, 2, 3. Okay. Write an equation in point-slope form. Now, to write my equation in point-slope form, I can use either of the 2 points it gave me. However, I would prefer to use this point because there are no negatives. So I'm going to say y minus y1 was 2, equals m, which is 2, times the quantity x minus x1, which was 4. Okay. Now write an equation in slope-intercept form. So y equals m, which is 2, plus b. And in this problem, b was minus 6. All right, problem C. A vertical line passing through the point -2, 3. So I'm going to plot the point, -2, 1, 2, 3. There's my point. I want to draw a vertical line through that point. So if I do that, it's going to look like this. Now, here's something interesting about a vertical line. This vertical line is never going to touch the y-axis. It's never going to touch the y-axis. So if they ask you what is the y-intercept for this line, put not applicable. It's never going to touch the y-intercept. Now, the zero is where it touches the x. Let me highlight it. So it touches the x at x equals -2. What is the slope? Well, hopefully you remember from our lesson on slope that the slope of all vertical lines is undefined. All right, now if I want to write an equation for this line, the equation would simply be x equals -2. In other words, all the x values, this is -2, 3, this is -2, 0. If I put a point down here, this would be -2, -4. In other words, x is always equal to -2. All right. Problem D. They want us to graph a horizontal line passing through the point 0, -3. So let's put a dot at 0, -3, right there. And they want a horizontal line through that point. So there's our horizontal line. So the y-intercept, well, it touches the y-axis at 0, -3. What is the zero of the function? In other words, where does it touch the x-axis? Well, this line never touches the x-axis, so not applicable. All right, what is the slope? Well, hopefully you remember that the slope of all horizontal lines is 0. And to write an equation. Now, for this line, I want you to notice this was the point 0, -3. Let's say I put a dot here. 2, 3, 4. This would be the point -4, -3. So notice on this line, every single y value is equal to -3. So this would be y equals -3. And that concludes today's lesson, graphing all forms of linear functions.